In the last segment, we talked about simulation models in enormous generality. Today I want to get more specific and look at an example of how a simulation model can be built and get some practice in designing classes along the way. So let's start by looking at the notion of Brownian motion, as shown by these red and blue dots moving on your screen. In 1827, the Scottish botanist Robert Brown observed that pollen particles suspended in water seemed to float around at random. He had no plausible explanation for this so-called Brownian motion and made no attempts to model it mathematically. A clear mathematical model of the phenomenon was first presented in 1900 in Louis Bachelier's doctoral thesis, The Theory of Speculation. However, unfortunately for Louis, since this thesis dealt with the then very disreputable problem of understanding financial markets, it was largely ignored by respectable academics, and in fact, he struggled to even get a job. 5 years later, however, in 1905, Albert Einstein, then a young man, brought this kind of stochastic thinking to the world of physics, with a mathematical model almost the same as Bachelier's, and a description of how that model could be used to confirm the existence of atoms. For reasons certainly lost on me, people seemed to think that understanding physics was more important than making money. I guess the times were different. Brownian motion is an example of something that has come to be called a random walk. Random walks are widely used to model physical processes, e.g. heat diffusion, biological processes, for example, the kinetic displacement of RNA from heteroduplexes by DNA. I hope some of you know what that means. I'm not sure I do. And social processes. For example, getting back to Bachelier, the movements of the stock market.